Dear learners, today in this video we are going to learn about potassium dichromate as oxidant. In potassium dichromate, chromium oxidation state is +6. So, chromium 6 as oxidant. Example, potassium dichromate. First, potassium dichromate, it is not a powerful oxidizing agent when compared to KMnO4, but it has several advantages over KMnO4. If you compare with KMnO4, KMnO4 is powerful oxidizing agent, yes, but it has some advantages over KMnO4. Next, this potassium dichromate can be obtained pure and it is stable up to its fusion point. Therefore, it is an excellent primary standard. So, potassium dichromate is the primary standard. If you prepare potassium dichromate solution, it acts as primary standard solution. Next one is aqueous solution of this potassium dichromate. Aqueous solution means the solution which is prepared by using water as solvent. So, aqueous solution of potassium dichromate is very stable over long periods if it is protected from evaporation. Okay, if the temperature is less, then automatically it will be stable for long periods. Next, potassium dichromate is used only in acid solution and it is reduced rapidly at ordinary temperatures to green Cr3+. So, chromium 6 will be reduced to chromium 3. So, potassium dichromate is not reduced by cold hydrochloric acid and it is less easily reduced by organic matter and is also stable towards light. But if you go for KMnO4, KMnO4 will be reduced by organic matter and it is not stable towards light. So, they are the main advantages of K2Cr2O7 when compared to KMnO4. Is it clear? Okay, right now. In acid solution, the reduction of potassium dichromate may be represented as the reaction, this reaction. So, dichromate ion in the presence of H plus, it can utilizes or gain 6 mole of electron. This dichromate can be reduced to chromium 3. So, due to the formation of this green color chromium 3, in visual titration at equivalent point, it can produce some green color. So, the detection of endpoint is somewhat difficult. Is it clear? Generally, chromium 3 color is green color. So, it is interfere with the endpoint color. So, that is the reason why in titrometric analysis with potassium dichromate, a redox indicator is employed for the determination of the endpoint or detection of the endpoint. So, in this potassium dichromate titration, why should you use indicator? Why? Because at the equivalent point, chromium 3 will be produced. So, this chromium 3 color is green color. So, it interfere with the color change. So, that is the reason why you need to add some indicators with potassium dichromate. Okay, what are the indicators? I will discuss it later. Okay, right. Next, potassium dichromate has special importance in the determination of iron ore because the presence of chloride ion has no effect in the determination. But in the case of KMnO4, HCl will interfere in the analysis. But with K2Cr2O7, it will not be like that. Okay, so it has special importance in the determination of iron ore. So the reaction is like this: dichromate in the presence of acid, it will react with ferrous iron to produce ferric iron. Is it clear? Till now we discussed about the introduction to potassium dichromate. Now preparation of solution, that is which solution? Potassium dichromate solution. For the preparation of 0.025 molar potassium dichromate solution, just take 6 gram of AR grade, that is analytical grade potassium dichromate in a glass mortar, and then heat it for 30 to 60 minutes at the temperature 140 to 150 degrees Celsius and cool in a desiccator. So what happens here? If any moisture content is there, it will be evaporated out, that is anhydrous. Next, now weigh exactly 5.88 gram of dry potassium dichromate and it is transferred into 1 liter volumetric flask and dissolve in water and make up to the mark with distilled water. You know very well this potassium dichromate preparation, you know very well, prati analysis ki chestha untaru. Okay, simple preparation. Just weigh 5.88 gram of dry potassium dichromate into 1 liter VF and make up with distilled water. Okay, after that, how can you standardize the potassium dichromate solution? Generally it is standard solution. Okay, but in case of impure potassium dichromate material is there, then you need to standardize it. Okay, so in case of impure potassium dichromate material, the aqueous solution of potassium dichromate should be standardized with metallic iron. So the standardization with metallic iron. So what is the process here? Yes, let us go with that. Insert a well-fitting rubber stopper having a bunt delivery tube into 500 ml CF. That is the just it is a arrangement. It is an arrangement. Okay, right, in CF, and clamp it at a stand in inclined position. Inclined position is like this. Okay, it is the horizontal position. This is the inclined position. Okay, inclined position, and then bent tube available being dipped into a beaker containing saturated NaHCO3, that is sodium bicarbonate solution. Inclined position అనేది NaHCO3 solution ఉన్న బేకర్లోకి పెట్టారు. ఓకే, నెక్స్ట్ ఏం చేయాలి? ప్లేస్ 100 ml of 1.5 molar H2SO4 and 1 gram of sodium bicarbonate into beaker, and then place 0.2 gram of metallic iron quickly into the beaker. అందులో metallic iron అనేది డిప్ చేస్తాం. ఓకే, రైట్. Now the flask is warm gentle until the iron is completely dissolved. జనరల్గా ఐరన్ ఏమవుతుంది? ఆ సొల్యూషన్లో డిజాల్వ్ అవుతుంది. ఓకే, రైట్. దెన్ కూల్ అండ్ టైట్రేట్ ద సొల్యూషన్ విత్ పొటాషియం డైక్రోమేట్ యూజింగ్ సోడియం డైఫినైల్ అమైన్ సల్ఫోనేట్, sodium diphenyl amine sulfonate or N-phenyl anthranilic acid as indicated, and the concentration of potassium dichromate can be calculated by using the relation 1 mole of K2Cr2O7 is equal to 6 mole of iron. So this is the process to standardize the impure potassium dichromate solution. Okay, next, what are the indicators? For visual inspection of endpoint in titrometric analysis with potassium dichromate, it is very difficult because of the green color chromium 3 ion that is formed in the reaction, what we discussed earlier. Thus, a redox indicator is employed for visual detection of the endpoint. So, what are the indicators used? Here, I mentioned three indicators. What are they? N-phenylanthranilic acid, sodium diphenylamine sulfonate in phosphoric acid, and DPA, you know very well, diphenylamine in phosphoric acid. So these are the indicators which are used for potassium dichromate titrations. Okay. Next, what are the applications of this potassium dichromate? Well known application, that is determination of iron in iron ore. So the iron ore sample is brought into solution by decomposition with concentrated HCl. Generally iron ore దేనిలో dissolve చేస్తాం, concentrated HCl లో dissolve చేస్తాం. Then ferric ion in the solution is reduced to ferrous ion by treating with stannous chloride solution. Okay. Next, then the entire solution, the ferrous ion solution is diluted with water, then add 1:1 H2SO4 solution and few ml of phosphoric acid and few drops of DPA indicator. Then this solution is titrated with standard potassium dichromate solution until a color change from green to violet blue is observed. So this is the reaction. So iron 2 combined with this potassium dichromate solution in the presence of acid media, it will be oxidized to ferric iron and dichromate will be reduced to chromium 3. So this is the process to determine the iron in iron ore by using potassium dichromate solution. It is one of the application of potassium dichromate as oxidant. Next one is determination of chlorate ion. Generally the chlorate ion is reduced by warming with excess of ferrous ion solution in the presence of relatively high concentrations of H2SO4. Generally after thoroughly mixing, the unreacted iron 2 can be back titrated with standard potassium dichromate solution. So it is a back titration method. So this chlorate ion excess iron 2 and H plus ion will be the reaction will be like this. Okay. Next, determination of chemical oxygen demand, that is COD, which is very important application of potassium dichromate. Generally chemical oxygen demand, shortly it is called as COD. It is an important application of dichromate. So COD determination. So in COD determination, what should you determine? We can determine the amount of oxygen required to oxidize all organic matter which is present in the sample of impure water. Okay. Then what is the procedure? Just place 50 ml of water sample into 250 ml conical flask having round glass neck which can be fitted with a water condenser for reflux. Okay. Right. After that add 1 gram of mercuric sulfate and 80 ml silver sulfate and H2SO4. Then add 10 ml 0.00833 molar standard potassium dichromate solution. Okay. Very less concentration. Then feed the flask with reflex condenser, you know reflex. Okay. Right. And heat the mixture. After that raise the condenser with 50 ml distilled water, means add 50 ml distilled water. Then unsaturated dichromate is back titrated with 0.025 molar ferrous ammonium sulfate solution. This is also back titration method. Record the titer value as A some x ml, that is some A ml. Okay. Repeat the same for blank means without taking the water sample. Okay. Let the titer value be B. So chemical oxygen demand equal to titer value, initial titer value minus titer value for blank into 0.3 into 20 milligram per liter. So this is the procedure to calculate the determination of COD which is present in the water sample. Okay. What are the applications of potassium dichromate? For the determination of iron in iron ore. Next, determination of chlorate. Next, determination of COD. Okay. Okay. Let me conclude potassium dichromate as oxidant. First introduction. it is more advantageous when compared to KMnO4. What are the advantages? They are the introductions. Next one, how to prepare potassium dichromate solution. After preparation, standardization of potassium dichromate solution. How can you standardize? By using iron. Okay. Next, what are the indicators used? Okay, right. Sodium diphenylamine sulfonate in phosphoric acid, N-phenylanthranilic acid, and diphenylamine in phosphoric acid. They are the indicators used. What are the applications? So, first application related to the determination of iron in iron ore. Next, determination of chlorate ion. Next, determination of COD, that is chemical oxygen demand in water. Okay, thank you for your attention to this video. Thank you.